So the next part we're going to focus in on is just simplifying algebraic expressions. So in order to simplify an algebraic expression, we have to know what an algebraic expression is. So an expression is a mathematical phrase that can contain numbers, variables, and operators. Operators are just plus, minus, divided by, multiplication. We also know that an expression does not contain an equal sign. So you can't solve an expression. We simplify an expression because there's nothing to solve for because there's no equal sign. A term is something within an expression. So a term is a constant or a variable in an expression, and they're separated by plus and minus signs. So each term is separated by addition or subtraction. So if something is being multiplied, that doesn't create a new term. Those are within the same term, and we'll see when we look at an example. Like terms must have the same base, so the same variable, and that variable needs to have the same exponent, which is the same thing as a power. So in order to be a like term, the letter needs to be the same, which is our variable, and that letter needs to have the same little number above it. So you have to have the same letter, same little number. So same variable, same exponent. That creates a like term. A coefficient is the number in front of a variable in a term. So the coefficient is the number that is attached to the variable. So it's directly attached. And what we know that those are attached by is multiplication. A constant is a specific number that is assigned a fixed value. So a constant is just a normal number. It is what we have been looking at in math since kindergarten. So it's a number without a letter beside it. That is our constant because it's always going to remain constant. It always holds the same value. So using these terms, I'm just going to label them in this example expression. So we said that an expression is just the mathematical phrase that doesn't have an equal sign. So this whole thing is an expression. We know that terms are the components within the expression that are separated by addition and subtraction signs. So my terms are the parts that are separated by the plus and minus signs. And when we're identifying our like terms, you'll see that the symbol gets included with the term to its right. So we would have an imaginary plus sign here since there's nothing in front of it. And this term has that sign attached to it. This 5 is really a negative 5. This 7x is really a negative 7x because you include it with the term that follows. A like term needs to have the same base, which is the same variable, and it needs to have the same exponent. So what I'm going to do is I'm going to square my terms that have an x with an exponent of 1, which is just no exponent. So we've got 2x, we have negative 7x, and we have negative x. So we know each of these terms are like terms because they all have a variable of x that has no exponent, which is just an exponent of 1. This doesn't get included because even though it has an x, it has an exponent of 2. My other like terms, so I'll highlight this in pink. These don't have anything in common with each other, so I'm going to give that one a diamond shape, and I'll give this a circle, just to show us how we think about the like terms and how we think about terms, including the sign that comes before them. A coefficient, like we said, is the number that's attached to the variable. So for 2x, it's the number 2. For negative 7x, it's negative 7. For 4x squared, it's the 4. And for negative x, this is the one that can always stump people. We actually know that the coefficient is just negative 1. It's not negative x because a coefficient is just a number. So you don't include the variable. You just think about what number is attached to it. What am I multiplying it by? So if there's nothing there, I can multiply by 1 and it doesn't change anything. And then last but not least, we have our constant. And my constant in this case is negative 5. So when we are simplifying algebraic expressions, which I think is the most important part of solving multi-step equations, because it can simplify anything that can seem really complicated, what we want to focus in on are these steps. So we want to remember the distributive property. We want to circle and square or box or diamond or triangle like terms to make sure we know what we're combining. And then we want to combine those like terms. So what we're going to do is look at 2 examples in order to do that. This first example says 9n plus 18, parentheses, 2n minus 6, close parentheses, plus 13. So the first thing I'm going to do is the distributive property. So the distributive property tells me that the term, the coefficient, not the term, directly attached to the parenthesis needs to be multiplied by the first and last, or just every term that's inside of the parentheses. So I'm going to do 18 times 2n, and I'm going to get 36n, and I'm going to do 18 times negative 6, and I'm going to get negative 108. So that is what I got from doing the distributive property. I need to bring down everything else that I didn't use. Next, I need to circle and square my like terms so that I know what it is I am combining. So I'm going to box my terms that have the variable n, and I'm going to circle my constants. Notice that I'm including the sign that comes before it. And then my last step is to combine my like terms. So for my squares, I have 9n and 36n. So that gives me a total of 45n. And then for my constants, I have negative 108 plus 13, which gives me minus 95. And because this is an expression, that's as far as I can go. I can't simplify anymore, so that is my answer. Let's try another example problem. So the next example says 3.5, parentheses, 10g minus 2, close parentheses, plus 17 plus 20g. So my first step is my distributive property. So I'm going to do 3.5 times 10g, and I'm going to do 3.5 times negative 2. 3.5 times 10g is 35g, and 3.5 times negative 2 is negative 7. I need to bring down my other operators and numbers and variables. And now I can circle and square my like and unlike terms. So everything that has a g variable, I'm going to put a square around. And then my constants, I'm going to circle. I can combine my like terms, so I'm going to combine this 35g plus 20g, which gives me 50g. I'm going to bring down these. So we did that. And then we need to add -7 plus 17, which just gives me, oops, this should be 55g. Sorry. Plus 10. I don't know why I'm mixing this up. So just a little bit more neatly written, 55g plus 10.